Hello, and welcome to today's video on how to complete 3 iterations of Newton's method to find an approximate solution to the equation x minus the cosine of x is equal to 0. Now, Newton's method is a method to approximate the x-coordinates of the x-intercepts of a graph. And it's an iterative method, meaning that you run a value through the process and you take the value you get out after running it through the process and run it through the process again, getting hopefully a more refined or closer approximation than the previous one. And you can keep doing that over and over to get closer and closer approximations to your original equation or x-intercept of your, or x-coordinate of your x-intercept. There are some situations where it actually does not get us closer to a solution, but for all of the problems that we will do in this course, Newton's method will work. So how do we do this? We will take our initial guess and put it in our table, and then what we'll do after that is run that initial guess through the function, run the initial guess through the derivative of the function, and then our Newton's method process is we take that initial guess and subtract off of it the function evaluated at that initial guess divided by the derivative evaluated at that initial guess. And we'll get a value out that will be our first iteration. Then we will bring that down into the next row of the table and do the process all over again. So when we're starting this and we have our equation that we want to use Newton's method on, that x minus cosine x is equal to 0, because we want to apply the process of Newton's method, we need to make sure that our equation is set up so that everything's on one side equal to 0 on the other side. So it's nice that this is already set up in that manner. When we have it that way, then our function we take is just the expression that's on the side opposite of 0. So we have our x minus cosine x. Now I've drawn the graph of f of x equal x minus cosine x just to the left of what I just wrote. And if you notice, the curve is crossing the x-axis really close to an x value of 1. So our initial guess is 1. So you want to get that from actually just drawing the graph of the function and seeing the integer x value that is really close to where the graph crosses. Now we want to find f of our x value, our first guess, and f of 1 is equal to 1 minus the cosine of 1. Make sure you set your calculator in radian mode, and when you run calculate 1 minus the cosine of 1, you'll get 0.45969766941. And that's what we will put in our table right underneath the f of x sub n. So we have our 0.45969766941. Next, we want f prime of x sub n. Well, f of x is x minus cosine x. So f prime of x is equal to, well, the derivative of x is 1 minus the derivative of cosine x is negative sine x. So the derivative f prime of x is equal to 1 plus sine x. For our f prime of 1, we get 1 plus the sine of 1, and f prime of 1 then is approximately equal to 1.8414700985. And we don't want to round these at all. We want to use this with all the digits in place, or we cause the problem not to be able to get the accuracy that we can get from Newton's method. So that's going to go into our table under the f prime of x sub n. So we've got our 1.8414700985. And now for our x sub 1, we are going to get that by taking x sub 0, which is 1, minus f of x sub 0, which is the 0.4596971, divided by f prime of 1. So divided by 1.8414700985. And when you calculate that, you'll have 0.75036 38678. And that's what we will put down underneath the x sub n and across from the 1, meaning that it's x sub 1. Now we're going to go through the process again. So we are going to take f of this 0.750363868, and once we run it through the function, we'll get our value out of 0.0189230,738. When we run it through the derivative, so remember we're running that 0.750363868 through the derivative as well, and you'll get 1.68190495291, and then we will take our 0.750363868 minus the quotient of 0.0189230,738 and 1.68190495291, and you'll have the next iteration approximation of the 0.7391128909. So now I'm going to just go ahead and fill out this table, and then you'll see what we have in our box under the x sub n across from the 3 will be our value for our third iteration. So here I've filled out the rest of the table, and our final approximation after 3 iterations is reporting that entire decimal expression there. So we have our x sub 3 is approximately equal to the 0.739085134. And that's Newton's method to approximate the solution of x minus cosine x equals 0 and completing 3 iterations.